Hello guys, so today we have a problem on cyclic functional equations. This might be like a little bit different from what we have seen up till this point, where we're usually dealing with substitution strategies and sort of like more or less similar problems and techniques and functional equations. But this is a little bit different. The problem looks a little bit different, but its solution is again fairly elementary and very interesting. So let's see how it goes. And this is the problem A1 from the Putnam exam in 2008. So Putnam is a math contest for undergraduates in North America, and it's held like I believe once a year, and there are it's held in like 6 hours, 6 hours for the day, like 3 hours in the morning and 3 hours in the afternoon, and then you have problems from A1 to A6 and B1 to B6. This is the first problem from the Putnam exam in that year. And in this video, we're going to be learning about solving some functional equations, the substitution strategy, which is like, as you might have seen, the most commonly used and probably the most important strategy when it comes to solving functional equations. Then we're going to see what cyclic functional equations are. And actually, if a functional equation is forming some sort of cycle, its solution is usually easy to find. And then after that, we have some book sessions of functional equations, and at the end, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so what's it telling us? So it's telling us that let the function f be defined from r square to r. Now r square is the plane. Okay, it's a plane. R square to r be a function so that f of x comma y plus f of y comma z plus f of z comma x is 0 for real numbers x, y, and z. Prove that there exists a function g defined from reals to reals so that f of x comma y is equal to g of x minus g of y for all real numbers x and y. Now here's the thing. Now this is the given functional equation to us, right? F of x comma y plus f of y comma z plus f of z comma x is equal to 0. So what is happening over here? Let's just analyze this for a moment. Let's think about what's happening over here. So let's say you have a function f, and in that you input x comma y, then you input y comma z, and then you input z comma x, and then you add all of these three quantities together, you get 0. So you have x, y, and z in like a cyclic manner, right? It's in a way a cyclic manner. X goes to y, y goes to z, z goes to x, and in a way when you add up all of these, this comes to 0. So it's in a way you can consider this as some sort of cyclic functional equation. So again, even in these types of functional equations, really the first thing that you should come to your mind is substitution strategy. And one of the things that we can maybe target is we plug in x, comma x comma x. So basically x equal to x, y is equal to x, and z is also equal to x, and that would leave us with f of x comma x plus f of x comma x plus f of x comma x is equal to 0. So that remains 3 times f of x comma x equal to 0. So f of x comma x is equal to 0 for all x belong to the reals, which is the domain given in the question. Now here's the thing, you might ask, why did I not start with something like x equals to 0 or y is equal to 0, z equals to 0? Well, you can try around with that, but the thing is that whatever solutions you get with that, whatever results you can get with that will always be a subset of this. Right? So this is in a way the generalized version. When I first saw this problem, yes, however, I did go for these 0, 0, 0 strategies, but in the end I actually saw that if you just plug in x comma x comma x, you get a general result that f of x comma x is 0 for all x, and that's really good because that in a way just simplifies the problem a little bit, right? So this was the functional equation given to us in a cyclic notation. So first we plugged in x comma x comma x. Now what I'm going to do is I'm going to plug in x equals to x, I'm going to plug in y is equal to y, and I'm going to plug in z is equal to x. Now you'll actually see why this is helpful, because I get f of x comma y plus f of y comma x plus f of x comma x is equal to 0. Now this quantity is obviously 0 for all x, right? We just proved that above. So we get the result that f of x comma y plus f of y comma x is equal to 0. So f of x comma y is equal to negative of f of y comma x. It sort of tells us that f is maybe behaving like an odd function. Okay. Now this is the second result that we had, and this is obviously for all x comma y belonging to reals, right? This satisfies for all. That's kind of the important thing to note. Okay, so let's return to the functional equation that they had given to us. X comma y plus f of y comma z plus f of z comma x is equal to 0. And let's try to maybe isolate this quantity. So f of x comma y would be equal to negative of f of y comma z, negative of f of z comma x. Sorry, should be z comma x, right? Now f of z, now I can write f of z comma x as negative of f of x comma z. So really what we're left with over here is f of x comma y is equal to f of x comma z minus f of y comma z. And this is essentially from the theorem, or from the result 2 that we had received over here, right? It's behaving like an odd function. Okay, now once we've received this, what can we say? Once you've received this, what can you say? Now here, an interesting thing that I can just do is I can just plug in z is equal to 1. So I'll get f of x comma y is equal to f of x comma 1 minus f of y comma 1. And you know, one thing that I can really do right now is I can just write f of x comma y is g of x minus g of y, where g of x is essentially f of x comma 1 and g of y is essentially f of y comma 1, right? And that would be the solution to the problem. So essentially that's what they had given to us in the problem to prove, right? We had to prove that f of x comma y is equal to gx minus gy for all real numbers x and y. And yes, that's what we had proved by just taking the fact that z is equal to 1. You just plug in certain value of z and it works out, right? So that's probably a nice solution to this problem. Okay, so coming on to certain book sessions of functional equations, you have functional equations by B.J. Venkatachala and you have functional equations how to solve them by Christopher G. Small. Both of them are really nice books. This one is a little bit of a advanced book, but it's really nice if you're preparing for team selection tests, IMO, etc., and the Putnam, of course. Okay, great. So we have a similar but challenging problem, and I wanted to find all functions defined from reals to reals with x greater than or equal to 0. So this condition is satisfied such that f of x squared plus y squared is equal to f of x whole squared plus f of y whole squared. This is kind of an interesting problem. Let's see how far you get with solving this, and if you're able to solve it or make any progress on it, let me know in the comment section below and I'll help you out. Until then, I'll see you in the next video. Thank you very much and bye-bye.
The programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.